Hey guys, Gazaz here. Hope you're safe and sound during this COVID-19 pandemic. Today we're gonna have a look at the Wannacry ransomware. The Wannacry ransomware is something which kind of shook the industry with its entry. It's a pretty interesting sample that we can analyze, and I will be showing you how we can use the tools and techniques for static analysis and behavioral analysis. So we will be probably like going under the hood and just to check what we have inside. Um, so starting with WannaCry. WannaCry is a ransomware variant, and obviously it has ransomware module within. Also has the capability to spread over the network. It will use your machine to propagate around the internet, infecting other hosts and also in your local area network. So it basically uses the Eternal Blue exploit by NSA. It was a infamous hacking tool dumped by the shadow brokers a few years ago. So it's a good sample to look into. There's a lot of activities which takes place when executed. So yeah, so let's get started. The first thing what we will be doing is we will be trying to open the malware in PE Studio. So PE Studio is a great malware initial assessment tool, which gives you some information related to like say virus total and imports, file headers, libraries, and all those things. So let me quickly show you guys that. Alright, so let me rename this to .exe. Alright, so, okay, it seems that virus total is disabled. Let's enable that. Right, so we can see that the number of hits it has hit in virus total. See, these are the variants we can see, and dot header, file header, right? Okay, sections. Okay, these are still loading. Libraries and imports. Like from imports, we can probably see the API calls. Uh, so it probably has things like sockets. So sockets which create some kind of connection, like things related to cryptography, and like there are pretty interesting stuff. Also, we can okay, so resources. So if you go to resources, you can see that we have an executable here, 1831, and the file ratio is 94.39%. So huge part, right? Um, okay, we can just get a fair idea just by looking at this information here. Okay. Right, so let's just move on, guys. This should probably load, and we can see all the API calls which it will be making. Anyways, we'll just move on. Okay, because the main things we'll be looking into is with the process hacker procmon. So we'll get on with that. we'll load up some monitoring tools now. So, what I'm trying to do is I'm just going to load up all these monitoring tools for now, and then try to execute the malware just to see, like, should show you guys what really happens. Right, so let's load up process hacker. This gives us a live view of what processes are going on and about. So this is something similar to, let's say, task manager. And then process monitor, right? So process monitor basically it looks for the processes being created, and based on the filters. Like, for example, I have the filters process create and process exit, so it'll probably be looking for the processes which are being created and exited by default for now. So here, and okay, we have DNS query. This is another good tool. Okay, I have already set it up, actually, like nothing much. Just you just have to navigate to capture options and select the adapter. That's it. So we already have some things going on, right? And last but not the least, yes. So this is okay, Microsoft Network Monitor. This is actually something similar to Wireshark. I opted out to use MS Snipmon rather than Wireshark because I felt this could be easier to showcase the filters easily. So it's kind of simple. And let's start it. All right. So we're good with the tools. We can probably execute the malware now. Okay. So just before that, what we will do is we'll probably clear. Yeah, we'll clear this, and okay, Control X. So I just cleared the process monitor and DNS query sniffer. So yeah, let's get back here. I'll just double click. Wow. Okay. So as you guys can see, like it got created and exited quickly. So nothing much happened, right? And we can check the sniffer here. So we can see some unusual, domain. So and it's green, right? So we can also probably check the netmon, the Microsoft Network Monitor. We can go to system. Probably it missed it because it was very quick. So let me just quickly check that. It should be a GET request probably. Okay, let's look in the unknown. No. Okay. Yeah, here we go. So what do we have? So you guys can see this, right? Like, so this is the domain which I was talking about. And as we can see that clearly here in the DNS query sniffer. So this is a domain. This is basically like it's a kill switch domain, right? So the malware is basically calling out to this domain to check whether if this domain is actually registered. If it is, then it won't infect the system. So this was actually identified by an infamous security researcher that this malware is actually looking for this kill switch domain, right? So you can see that we are still not infected. But this was not the case when this malware was released in the early days, right? When it propagated via the internet through organizations and across the globe. So now what we have to do is, like in our environment, what we can do is we can trick the malware into running. So for that, we'll probably be digging into the code. Um, we can load up this malware, as in this sample, in x64dbg. It's a debugger, right? You can use x32 if your system is. I mean, it basically depends on the file type, right? So if the file type is 32, then 32. If it's 64, it's 64. So what I have in my system is actually it'll have both. So it says, let me show you guys that. Yeah, it says x96. So if I open that up, it will give me the options x32, x64. Let me show you in x64. It's not going to work, but I'm just going to show you that it's not going to work. Right, so let me load that up. Okay, so it says use x32dbg to debug this file, right? It's not going to work. So what I'll do, I'll just close this, and maybe the easiest way, just drag and drop it here. It'll pick up the 32 and it will load up. So once it's loaded, the first thing we should do is press F9, right? So we'll load up the main module, and when you load a binary into this debugger for the first time, it's best to check for the string references. So to check the string references, you just have to go to right click, search for current module and string references. So okay, so here you can see some familiar things here, right? Okay, create process, create file, write file. This look like API calls to me. Okay, okay, these are probably decimal numbers, as in IP addresses maybe. Uh, Probably hard-coded IP addresses, and it's a service here. All right, so we know this string. We've already seen that in the DNS query sniffer. Okay, so we can. Okay, so let's just get on with what we already know. I mean, we found this already, right? Like, we can see like what happens and dig around a bit, right? Um, yeah, actually, that's a good way to finding like jumping off point to start analyzing malware. Um, what we can probably do is, okay, just a minute, guys. So, like, what we can probably do is just jump into that address and check that specific code of this thing. I mean, piece of code. Because probably it's a daunting task to start from the entry line and move through each line to see what the malware is doing. And if you're doing that, then you'll be probably spending days working on it, right? So you probably need to have a idea as to where you should be starting, and like working your way through. So in this case, let's look at it in the behavioral analysis point of view, since that's quite interesting, right? and so we would we can probably go have a look at the associated code, what the logic was around that host name, and how we can trick the malware into running. But before that, I was just thinking whether like we can dig deeper and just see what we can find. Like we can find other things in this within this malware and within this sample file. So for that, I'll probably load this up in PE Studio again, and we'll just see. I just want to check that resource again. So let me get this here for a bit. Okay, let me we'll leave it like that. And okay, PE Studio. Right. So 1831. And we have code. I'm just checking the bytes and okay. All right, we can try. We can dump it to resource hacker. Okay. The same file name 1831. Maybe it cannot be run in dust mode. Okay, maybe we can just dump this and dump this. Okay. Let's save it as 1831. Now let's delete and save it as it is. Close and okay. Well, we can load this up in PE Studio again. Alright. So 68 out of 72. Detections. The variants we can find. And resources. Okay, it's a zip file. Yes, and the ratio is 98.06. So that's it. We can maybe check again in resource hacker as well. Um, 258. Okay, not sure. Just X bytes and okay, we can confirm it's a zip. It's a zip file. Probably what we can do is, since it's a zip file, maybe we can try extracting, right? So send zip extract to, of course. Why wouldn't it ask for a password? Yes. Um, Now to find the password, um, okay, so this is a self-extracting zip file. Then which when the Wannacry exe starts, so it's gonna get extracted and I mean it's gonna extract the resources and unzip it. And we can guess that this is a hard-coded password should be available in within the code, right? So we should be able to have a look. Okay, we can load this up in X32, right? Okay, load it up. So again, we can press F9 and then probably check for the current module string references. Okay, can find interesting words here, like create file, write file, read file, move file. Okay. Maybe we can look for resources. We'll go back here and search for current module, into module calls. Okay, let's look for resources. So find resource. Okay, so find, load, lock, size. So that's a bunch. Um, let's have a look in the code. Okay, so it's all together here. Very good. Okay, so it starts. Okay. Return and then push adp, move and sub. Okay, starts at 401 BAB. Yes, okay, and it calls file resource lock load. Okay, so what we need to figure out is when something happens to resources, what's calling this function, right? So we can probably right click and find the references. Oh yeah, let's go for references and good. Fortunately we have one, so let's click on that. Is the one. Grant everyone. Okay, we have something here. Okay, that looks like a password, right? So we can, well, let's try to copy that. Selection. Let's open up that. Copy. Okay, let's see. Okay. So that worked, right? That worked. Okay. So we can see. Okay, we have files here. Let's try to group it by type. Okay. So we probably will not be going through like each of these files in detail, but maybe like let's just run through them quickly. Okay, so task DL exe is something responsible for cleaning stuff up, maybe. And then there is task se, so probably spreading the ransomware. And then the message folder, so okay, so this contains the messages like you get when you're infected, and it's in several languages. Right? Okay. Right. So b dot one. We can open this up in probably hex decimal. Let's do this. Okay. Um. What is this? I suppose that should be the. Let me check again. Looked like a. Hmm, probably an image, maybe. Yeah, let's. I think it's probably some image. So what we can do is let's try to rename this. Oh, yeah. Okay. So this is actually okay. So this is the wallpaper which you will get once you are infected, right? So okay, so that is that. Okay. Maybe we can rename it back to WNY. Um, what else? So C. Yeah. All right. So this is something related to toll. Yes. Yeah. So okay, probably something related to toll. That's what the other one are. What's wrong with my file? It's your okay. So this is the message, right? The ransomware message you get once you're infected. Um, yes. Got a PK. It's PK header, so it's zip file probably, and maybe we can try unzipping this one. Yeah. I hope it doesn't ask for a password. But yes. Okay. Alright, so this is mostly related to toe, as we can see. It's alright. What else? So T. Looks like some encryption. Okay. So guys, we will not be looking all of these files in detail. So I mean, it's a daunting task actually. It'll take a lot of time to go through each and every file. So the purpose of this video is to just get inside the malware and see how we can trick the malware into running, and just to get an idea how things are working. You know. Um, so yeah, let's check the last one. U. NZ. Remember, this header looks like an executable. Probably in this mode. Some decryption. Yeah, I think this is something related to decryption. Okay. Um. So that's pretty much about it, right? So you guys can dive deep if required. Um. Yeah. I'm gonna exit the X32 for that file. So that's pretty much about it. So we found that we have several and resource inside it and resource within resource. So now probably we can carry on with the tricking the malware to run. So let's do that. We'll close it up. Yeah. And we have our file now. Okay. Now what we can do is we already have the um we already know the string, right? So this domain, when we double clicked on the malware, a DNS request was made and it was successful for this domain. It was a kill switch. So what happens if we disable this kill switch? If we trick the malware just to skip this part, right? So let's navigate to the code, and as usual we have to do the F9, right? We can go to the oops, what did I do? F9, right? So we can get to the entry point, and so search for current module, bring references. Okay, then go here. All right, now we have a couple calls here. Okay, so the call to internet open URL1, the URL A, and then a handle. Looks like a handle. Okay, yes it is. Right. So what we did was we just clicked on the domain string and we navigated to the portion of the code that uses the string, right? So you don't have to necessarily reverse engineer each line of code. Like you can if you want to, but if you want to understand each line of code maybe. But I already had a glance at it. So if you look here, the So just a minute. Okay, okay, yeah. If you look here, there is one API call here, Internet Open A. So it probably has some parameters somewhere here. Maybe the version has changed. Right. Okay. So basically, like when you make an API call, you pass in some parameters for this Internet Open A and Internet Open URL A, right? So when they are successful, you will be returned with a valid handle. So first off, you will be returned with a valid handle for the internet connection generated, and then like store itself in the EAX register. So the EAX register is up here, right? So uh, it's basically the general purpose register, right? So the same applies for Internet Open URL. You will have a value returned to you in EAX. Should that be successful connection to that weird URL or the domain? So let me close handle. Okay, so let me put a breakpoint here, right, on this, and okay, so F2, right? You can just press F2 or right click and breakpoint toggle. So either way, and then you can run. Okay, so it stops there. I'll remove the breakpoint and I'll move to the, so as you can see here, okay, so the EAX, it's 00cc, 000, and when you move to the next instruction, okay, it changed, right? So it changed again. We will be doing another jump in the instruction. Okay. It's gonna change the value, right? I'm gonna, okay, so if you saw that the EA, like the EDI value changed to match EAX, right? Okay, what we can do is, so watch closely here, guys. So it actually changed. So then we can go to the next instruction, goes the handle, right? And then um there is a test of EDI to test whether the value of EDI is 0 or not, right? As in this value, it's a test to verify whether if this value is 0 or not. So there is a conditional logic instruction here. It's a conditional jump, right? So JNE, it means jump if not equals to. So jump if not equals to what? Jump if not equals to 0. So if it's not equal to 0, that means there is a value in EDI, and therefore it is a valid handle, right? And if it is a valid handle, the code is gonna jump down to probably, okay, jump is taken to here, right? So I think this, if this test is valid, so it makes yeah, you can see here, right? The jump is taken. When you click here, the jump will be taken. So it will skip this Wannacry.port 40 80 90. So if the jump is not taken, only then the infection will take place, right? So basically, if there isn't a valid handle, so that basically means the kill switch has not been activated yet. The domain is not registered, and the code is gonna continue without jumping and land at WannaCry start 40 80 90, right? So this API call. Right. So we can also check this in the graph view. We can press J. Doesn't work, does it? Let me. Oh, it's G. All right. So okay, on the side, right? So if the jump is taken, that means it'll go. I mean, it'll take this green line, right? If the jump is not taken, it'll take the red line. So it's pretty clear here. We can move back to the CPU. So we are still here, right? We are here, and um, let's do the trick, right? So move to the next instruction. All right, and then one below. Okay, we can move here as well. Okay. We'll make another move. Now the jump is taken, right? So jump is taken as in, if this I mean, if we run this, it will not get infected because the jump will be taken, right? Because there will be a valid connection, the kill switch will be activated, and therefore no infection. So we can change the zero flag, right? So this in E flags register, the zero flag is set to 0. The value of EDI is not set to 0. Yes, so we can change that to 1 by just double click, right? So why we do that? To trick the execution to thinking that EDI is now 0. Now if you look below in the left side, see, it says jump is not taken. Let me go back to 0 again, right? So it says jump is taken, and if I see, let's say 1, the jump is not taken, right? So it's gonna obviously infect the system. So that's it, guys. Like basically, I think we did a couple of things. Okay, we can carry on with the infection. I'll just say, if I just press F9, it'll just gonna go hit. I mean, get executed. Before that, I'll just show you. I mean, we can monitor them as well. See, it's in. If you see X32, Wannacry is there. I mean, it's still holding. Let's see, process monitor. We can play some stuff here, and then DNS query sniffer, Control X, and what do we have here? Okay, maybe we can play this. So not required. Not necessarily required. Okay, and before you infect yourselves, guys, make sure that you isolate the VM from your network, right? So your VM should be actually on a bridged network with direct access to the adapter, not through your host, right? So it should be a bridged network. So that is the safest way. And in case if it is connected to your NAT, so it's only safe if you have a better firewall and a good antivirus software, right? So but I would always recommend for you to go for bridge network as it's more safe. And so this is using this is a Windows 10 machine, and it's outdated, nothing is updated, there is no antivirus, and the VM is using bridged network, right? So that's how I have isolated this VM from my host system. So all right, guys. So if I just press F9, um, given that this is one, it's the jump will not be taken, and it's gonna execute this, right? So let me show you guys that. All right, I just hit F9. Let's check the process monitor. Okay, nothing much. Nothing much here as well. Okay, we still don't have anything. We have something here. Mhm. Probably the system. I mean, it takes a while, right? So I think it's better if I pause it for a bit. This video will be a bit lengthier if not. So let me pause for a bit. Alright, so it kind of took a while, right? So okay, task chain. How will you pronounce that? Okay, so we got a couple things running here. Um, task chain, CS split, and okay, more tasks here. Let's check the actually doesn't have much. Okay, network monitor. I mean, we know for sure it's infected now, right? Let's take a look at the desktop. Okay, we can see some additional desktop icons, and probably let's look at some files. Yeah, so all of them are encrypted now. Okay, so if I double click, let's see what we get. Yeah, nothing. It's a .wn try. It's still running for sure. The background should change, and we will be popped up with um, a message box kind of thing. So should be up any minute. Um, so yeah, so that's pretty much it, guys. So this system is infected now, right? And it's gonna be very persistent. That the when the pop-up message appears, it will never go away. As in, it will you can close that, but it doesn't mean it'll go away, right? So no matter if you close it, reboot, delete, it will just keep popping up. What we basically accomplished is, like, we tried executing the malware, but the system did not get infected because the kill switch domain has been already registered now. And then we dissected the malware and digged into the files with it, found some interesting stuff. For instance, like the pkzip file and the password per se. And further on, we tricked the malware into thinking that the domain is not registered. The EDI value is 0, and it got and we got it infect the system eventually. um like, make sure you try this out in a safe environment, as I mentioned earlier, right? So we will probably make mistakes, but just to be on the safe side, use a VM and be on the bridged network, right? You can find the sample in the description. And also probably I'll be doing a write up, and I'll give that link in the description as well. So hope this was helpful for you guys. Probably it was too slow, or maybe uh, if I have missed anything, you can just put in the comments so I can clear that up. So you guys can see here, right? It'll show up for 24 hours. Yes, yeah. So 24 hours, and these are the things which we already digged up into, right? We saw all these messages, and these messages are in different languages. And the Bitcoin wallet, right? So check payment, when you pay and you get the code or something, and you'll be able to decrypt. Contact us, how to buy. Just maybe I can just close this for a while. It'll pop up any minute, right? It'll pop up again. I just want to show you this background. So we saw this when we were trying to check the resources from the pkzip within the malware, right? So this was there. It was a image file, probably. It could be anything like bit. Usually it'll be bitmap, right? Maybe I think I tried with JPEG probably. See, so it'll just keep on popping. The wanna decrypto, so it also says to, right? So that's it, guys. So that's pretty much it. I'm just gonna, you know I'll probably close power off this VM and restore to my previous snapshot. Always have snapshot, guys. So snapshot is, it's what saves you from any mistakes, and make sure you don't infect your host system by using network, like the, what do you call that, network. um I'm not sure what you call that, but the net, right? Net. So don't use that. And even if you're using that, I would advise you to use proper antivirus software, right? And good firewall. So that's it, guys. Thank you for watching this video. Cheers then.